We have a clear no line reference question, but here we know what we're supposed to do with any no line reference question for the no reading strategy is we're supposed to follow the chronology rule if we can. Let's look at other questions nearby, figure out where those questions tell us to read, and because the questions are in the basic order of where the answers are in the passage, we know that's going to tell us where to read for number 44. So 43, if we didn't think about the right answer, we would just look, okay, it's somewhere in the first paragraph or two, and then 45 is in line 31. So the answer to number 43 was C, so maybe we start there, but even still, even if we start at line 1, we're not reading the entire passage, we're kind of reading the first paragraph or two, maybe into that third paragraph, just to kind of look for this answer. And even though that's a little bit more reading than usual, it's less than the full passage, and the no line reference questions almost always tell us like very specific things to look for. So we're looking for something about old galaxies billions of years ago. So as I'm looking at this, I'm not reading it to understand every single nuance. I'm kind of just reading for anything about, they tell me about the galaxies, about their age, anything like that. So I'm going to read kind of fast here. The Hubble Space Telescope is a time machine starting not only billions of years into the depths of space, but also billions of years back in time. And its extraordinarily sensitive detectors above Earth's surrounding and blurring atmosphere, HST, can witness the peak of star formation at a cosmic high noon, which ended about 5 billion years after the Big Bang. And at the outer limits of its capabilities, we wonder if it could detect the faintest candles of creation, the earliest galaxies made of the earliest stars at cosmic dawn when the universe was less than a billion years old. So we needed to look for something about old galaxies, and we seem to be getting it. Those were the hopes of two of us authors, Faber and Ferguson, after NASA astronauts installed HST's Wide Field Camera 3 in 2009, which enabled Hubble to survey the infrared sky about 30 times faster than before. Within a few months, Hubble pointed a new camera at the Hubble Ultra Deep Field, a tiny region in the constellation Fornax, only a tenth the diameter of the full moon, and took exposures totaling about 3 days. Those deep HUDF images revealed some of the most distant galaxies ever found, which look very different than nearby galaxies, but HUDF represented just a pinprick poke at the universe. Notice that in all that paragraph, I only highlighted one thing. That's because so much of it wasn't about the galaxies, it was about how they looked at the galaxies. I don't care about that. The question is asking about the galaxies, and only at the end do they tell me something. They tell me they're different. I don't know how they're different, but they're different. So maybe I'll keep reading. So we began an ambitious program at visible and near-infrared wavelengths as a natural successor to HUDF, the Cosmic Assembly, Near-Infrared Deep Extragalactic Legal Survey, pronounced candles. We designed candles primarily to document the first one-third of galaxy evolution. The program would also enable astronomers to search for the most distant type Ia supernovae, exploding white dwarf stars that are the best-known standard candles for measuring the universe's recent expansion rate. Candles could thus test whether Ia supernovae are also a valid yardstick for the early universe. Okay, so literally, they're talking a lot about how they looked at the galaxies. Then they talk about specific things that they looked at, but they're not talking about the galaxies. They're talking about stars. They're talking about supernovas. So that's not relevant. So let's go to our answers here. What can be reasonably inferred about galaxies billions of years ago? They looked very different from galaxies from today. That's like literally the same thing. Now, in the highlighted lines, they don't explicitly say that those are the old billion-year-old galaxies. But that's where the paragraph above comes in, right? That's where the other piece of the question comes in, that they are looking specifically at the old galaxies in the first paragraph, and then when they looked, because of the way the telescope works, this is what they saw, different looking things. Therefore, the old galaxies must look different from the galaxies today. So it's pretty much the answer. I mean, do we really have to read B, C, and D? Yeah, but they're going to probably not work. Let's take a look. They were dominated, very strong word, by type Ia supernova. So, no, they did talk about those, but they don't say that those are the main thing that they're seeing. They're saying that when they look at this little area of the sky, they're looking for this specific type of star, but it doesn't tell us any sort of proportion about how many of that star there are. In fact, it almost implies that there aren't many and that searching for them is kind of hard. So it dominated, very strong word that I'd be nervous of anyway, but I would really need to prove that, and there's just nothing about the proportions here. C, they were grouped together in one location in the sky. Well, they looked at one location, but that doesn't mean that these galaxies were only in that location. That's not what they say at all. They just happened to look and pointed at one spot. That's totally different than saying that they're only in that spot. D, they were much larger than astronomers had expected. Well, I don't remember reading anything about size. Maybe I missed it, but I'm pretty sure it's not there. And A was better anyway. So there you go. The chronology rule narrows our focus to just a small piece of the passage where we're likely to find the answer. We can always read more, but very, very often we get what we're looking for where we'd expect it to be. And so this is much easier, especially in a science passage where things are dense and confusing, especially in a history passage where we might not understand the language. It's much better if we can use the question and the choices, the things that we will understand, to summarize what we're going to look for and to go into these dense passages with a few clear ideas in mind. We want to read with purpose, right? I was able to read fast through most of this stuff because I knew that it didn't match my purpose, right? I was looking for something about old galaxies. And when I found it, I stopped and read a little slower. But for most of it, I was just able to breeze right through it. That's how we're supposed to do the reading. You don't need to understand everything. You just need to understand the thing that they're asking for.